Yeah, hello fans. We want to look at this Igcse equation. The question says a geometric progression is such that the first term is 4 and the sum of the first three terms is 7. Find the two possible values of the common ratio. And B says the sum to infinity for the convergent progression. So we start this way. Solution. Our first term is 4. Then we have that A is equal to 4. Our sum of the first n terms of a GP Sn is equal to A into 1 minus R raised to power n over 1 minus R. So we always use this if the absolute value of R is less than 1. But we are given that the sum of the first three terms is 7. So we have that S3 is equal to, our A is 4, we have 4 into 1 minus R raised to power 3 all over 1 minus R. So, and the value is equal to 7. You can recall this identity when you have A raised to power 3 minus B raised to power 3. The value is A minus B into A square plus AB plus B squared. So we use this identity here. 1 can be written as 1 raised to power 3. So we apply difference of 2 cube property. So from here, we can rewrite this as 4 into 1 minus R, 1 plus R plus R squared over 1 minus R. And we say this is equal to 7. You can see that for free, that if 1 is acting as A here and R is our B, so you have 1 square, which is 1 times R, which is R plus R squared. That's exactly what we have here. So from here, I'm free to cancel out. If I cancel out, I'll have 4 times this. So I will use this 4, open this bracket. What I will have is 4 plus 4R plus 4R squared equal to 7. When I rearrange and bring this 7 to this side, I will have 4R squared plus 4R plus 4 minus 7 equal to 0. So if I rewrite, I will have 4R squared plus 4R minus 3 equal to 0. So I will multiply these two. If I multiply these two, I will have minus 12R squared. Let me look for two numbers. When I multiply them, I will have minus 12. When I add them, I'll have plus 4. So those two numbers are plus 6 and minus 2. So that's what will give us the two values we are looking for. So I will just come here and open two brackets, R, then equal to 0. Then I will now fill plus 6 minus 2. I will now divide by the coefficient of the quadratic term. Divide by 4. Divide this one by 4. If I divide, I'll have 3 over 2 here. Divide, I'll have 1 over 2. So we have achieved that R plus 3 over 2 times R minus 1 over 2 is equal to 0. So when we set each of the brackets to be 0, we have that our R is equal to, if this one is equal to 0, we have that R is equal to minus 3 over 2, or this one 1 over 2. So if you watch, for the progression to be convergent, it means that the absolute value of R must be less than 1. So let's check for the absolute value. The absolute value of minus 3 over 2 will give us 3 over 2, and which is greater than 1. Then the absolute value of half will still give us half, which is less than 1. So in this case, working with this R will make this progression defined this way to be convergent. If you work with this R will make the progression to be divergent. So if you watch closely from the second question, the second question said find the sum to infinity for a convergent progression. So for this progression to be convergent, it means we are working with this R. Then our sum to infinity, S infinity, we are working for B now. So this is our answer for A. A, the two R's are -3/2 and 1/2. Then our sum to infinity is A over 1 minus R. So this is the R we are working with, half. So our A is 4. Have 4 into 1 minus 1/2. So if you do that, you have 4 over 1/2. You can see for free, I can rewrite this to be 4 divided by 1/2. If I change this division to multiplication, I will have 4 times this one will flip 2/1, which is equal to 8. So what we have achieved is that the sum to infinity for this convergent progression is equal to 8, and that's the final solution. Thank you. Bye.